All right, let's talk about Newton's second law of motion. We've explained Newton's first law of motion, but in the course of that video, I forgot to write the formula to Newton's first law of motion. I said that he found a relationship between force, mass, and acceleration, and he makes the formula to be force is equal to mass times acceleration, which they make F is equal to ma. This is the formula to Newton's first law of motion. In fact, most of this formula we use if we were asked to calculate for force when we are given mass and acceleration. But in this class, we're talking about Newton's second law of motion. Now, it states that the rate of change of momentum is proportional to the applied force. What does that mean? In fact, you've seen this word here, momentum. What is momentum? Now, first of all, I'll explain what momentum is. Then we'll explain or give the formula, derive the formula to this second law of motion. Now, what is momentum? Momentum, it is symbolized with this alphabet, with this symbol rather. We call it rho. Rho. Now, momentum is the product of mass and velocity. Momentum is the product of mass and velocity, which makes momentum to be equal to mass times velocity. Mass is symbolized with m times v, which is equal to mv. This is the formula for momentum. Mass times velocity. And this sign symbolizes rho. We call it rho. Right? Now, this second law states that the rate of change of momentum, when we talk about rate should take our mind to time. Or something should be all over time. That is rate. The rate at which something happens is when that thing all over time. Alright? Now, the rate of change of momentum is proportional to the applied force. What does it mean? Now, it means that this is the force. When something is proportional, we use this sign. This is the sign of proportionality. Alright? It's directly proportional to the change of this is not, I'll write it here, momentum. Now, this is all these things here now. This is what it means. The force is directly proportional to the change in momentum. But we said it is the rate, so all over time. Can you see how they are deriving the formula? It states that the rate of change of momentum, this is change of momentum, but the rate at which that momentum changes is directly proportional to the force. What does it mean? It means that if we say something is directly proportional, it means that if force is increasing, the change of momentum will be increasing. But if the force is increasing, the time will be decreasing. Yes. When we say something is directly proportional, as the force is going up, the change in momentum is going up. That's why it is directly proportional. But if it is inversely proportional, if this is going up, this will be coming down. That is inversely. But this is directly proportional, right? But we don't need to go to this side. We don't really have a business here. Now, let's derive the formula for that. We have force, which is this. We change this proportionality sign equal to the change in momentum. Now, change in momentum will be delta. This is called delta or change in. Okay, delta m change in momentum. I'm saying momentum is mass times velocity. All right. You see how we are deriving? So change in momentum is delta mv all over t. But in a situation where we are given final velocity, I'm going to solve questions on these laws of motion. In the situation where we are given final velocity and initial velocity, previously when we were dealing with resolution of vectors, we talked about initial velocity, final velocity. We talked about in projectile, we also talked about final velocity and initial velocity. So if we are given final velocity and initial velocity, we'll be having F is equal to mv minus mu all over t. This is when you are given this v stands for final velocity, u stands for initial velocity. But in mathematics, we can do something to this. Then we have f is equal to, what is common here? We call it, we factorize. What is common here? M is here. So we just bring m, open the bracket. This you're having v minus u all over t. This is the formula we use when we are given the final velocity and the initial velocity. Alright? This is the formula we use when we are given the final velocity and the initial velocity. So it's this Newton's second law of motion. It states that the rate of change of momentum is proportional to the applied force. I've explained what momentum is, the product of mass and velocity, and I talked about this symbol, which is rho. And we derived the formula F is directly proportional to the rate of change of momentum, which is change of momentum all over time taken. Then change of momentum is delta mv. This sign represents change of delta, change of. So you're having delta mv all over t. Now, when we are giving initial and final velocity, you have, this is your final velocity minus the initial velocity, which is that change. The change, it changes from final to initial. That's why we see change. So you subtract both of them. But in this case, we factorize. M is open brackets, this v minus u all over t. This is the formula to solve. I will solve questions. This might not look very clear to you, but when I start solving questions, you begin to understand this formula. Please subscribe to my YouTube channel, follow my Facebook page, and like, drop a comment, and share. Thank you.